Okay, so today in our unit on algebraic problems, we're looking at old-fashioned problems and we'll also look at age problems. So here's our first example. So for these types of problems, it's a good idea to draw yourself a diagram. So there's one drawn here already. So let's read our question. 1/2 of a post stands in the mud. So that's shown here. 1/3 is in the water, shown here, and the remainder, which is 6 decimeters, is above the water, shown here. What is the whole length of the post? So we need to calculate like the total length of this post. All right, so we just have to add all of these up, and we don't know what the total is. So half of x, plus 1/3 of x plus the 6 is equal to x. Okay, that's what we're trying to solve. What is the total length of that post? All right, so next we can bring the x over to this side so that we can collect like terms, and we can subtract the 6 over to this side. So we'll just show that in one step here. I'm going to subtract the 6 and I'm going to subtract the x on that side. All right, so we end up with half x plus 1/3 x minus x is equal to -6. All right, so next we have to collect these like terms here because they all contain the x. So we just have to come up with a common denominator because we're adding fractions. So a common denominator is going to be 6 for all of them. So I'll just show that here that I'm using 6 as the common denominator. So that makes this here become 3x. This will be 2x. And then here we'll have the 6x. And all of that is equal to -6. All right, so I'm just going to bring this over here. So we have 3 plus 2 minus 6, which gives me -1. -1x over 6 is equal to -6. All right, so next I will multiply both sides by the 6 to get rid of this 6. I'll just show that like this. I'm just going to multiply by 6 on both sides. That'll cross this out, and we're left with -1x, which is equal to -36. And the last thing we have to do here is get rid of that -1 by dividing by -1 on both sides. And finally, we're left with x is equal to 36. All right, so what did we just solve for? We solved for the whole length of the post. So the last thing we have to do is our sentence, which is the post is 36 decimeters long. All right, so our next example. So a man deposited a total of $160 in 3 deposits. So in this one, we know the total. It's given to us. The second deposit was double the first, and the third was $4 more than the sum of the first and second. What amount was deposited each time? So the first thing we'll do here is we have to figure out what is the first deposit, what was his second deposit, and what was the third deposit. And we already know that the total is $160. So I'm just going to put that down here. We know that the total is $160. Okay, so we know that the second deposit was double the first, and the third was $4 more than the sum of the first and second. So therefore, our first, we're going to call x. Our second deposit was double the first, so double means we're multiplying by 2, so that's going to become 2x. And then the third deposit was $4 more than the sum of the first and second. So the sum of the first and second, we have x plus 2x, which gives me 3x. And it's $4 more than the sum of the first and second, so it's 3x plus 4. All right, so now if we add up all of these, our sum total is $160. So we have x plus 2x plus the 3x plus 4 is equal to 160. All right, so now we can collect our like terms. So we have x plus 2x plus 3x, which gives me 6x, plus 4 is equal to 160. Looks like a type 2 equation. So we'll subtract 4 on both sides. So we have 6x is equal to 156. And then we're going to divide by 6 on both sides. And that gives me x is equal to $26. All right, so now if we go back here, that means the first deposit is just x. So it's just 26. And, okay, just a mistake here. This should be 156. I can't erase it, so I'll just have to write on top of it. So 156 divided by 6, which is $26. All right, so if we go back here, so that means our first deposit was $26. Our second deposit is going to be 2 times $26, which is $52. And then the third deposit is going to be 3 times the 26 plus 4, which is $82. All right, so now in our final sentence, we would say he deposited $26, $52, and $82. All right, so this next example, a farmer bought 3 oxen, 4 cows, and 6 calves for a total of $260. He paid twice as much for a cow as for a calf, and then twice as much for an ox as he did for a cow. How much did he pay for each type of animal? So let's say the calf then would be X. The cow here, he paid twice as much for a cow as for a calf, so that would be 2X. And then the next one is twice as much for an ox as he did for a cow. So for the ox, it's twice as much for the ox as he did for the cow. So it's twice the 2x. All right, which gives you 4x. All right, now when you guys are putting this into the equation, don't forget that there's 3 oxen. So there's 3 times the 4x. And then there's 4 cows, so 4 times the 2x, and there's 6 calves, so 6 times the x. So just applying now that there's 3 oxen, 4 cows, and 6 calves. So when you're putting this into your expression, there are 6 calves, so that means this would have to be multiplied by 6. There are 4 cows, so this would have to be multiplied by 4. And there are 3 oxen, so this here would be multiplied by 3. Then you can add them up, and we know our total is $260. Here. So our equation would look like this. It's 6x plus 4 times the 2x plus 3 times the 4x is equal to 260. All right, let's just finish this up then. All right, so here we would end up, we have 6x plus 8x plus 12x equals 260. Let's add that up. So 6 plus 8 plus 12, we get 26x equals 260. Divide by 26 on both sides. And that gives us that x is equal to 10. All right, so we have to go back to our original expressions there, that the calf is x. So therefore, the calf costs $10, and then it's 2x for the cow, so $20. Cow costs $20, and then it's 4x for the ox, which is so becomes $40. And the ox is $40. All right, and it was because we were looking for each type of animal. All right, so next we are looking at age problems. So when we're solving age problems, it's useful to use a chart shown like here for this example. So the first example, a father is now only 3 times as old as his son, but 8 years ago, the father was 5 times as old as his son. Find their present ages. All right, so the father is 3 times as old as his son right now. And then we have the past because we're looking at 8 years ago. So we'll call the son X, and then the father is 3X. All right, and we get that from the question that the father is now only 3 times as old as his son. Okay, so that's that. So the past, this would be 8 years ago. All right, so that means we have to subtract 8. So we're going to take 3x, subtract 8, and then the x, and we're going to subtract 8. All right, the only additional information here is that 8 years ago, the father was 5 times as old as his son. So we do have to incorporate that when we set up our equation here. So we have 3x minus 8 is equal to 5 times the x minus 8. All right, so now we can go ahead and solve. So 3x minus 8 is equal to 5x minus 40. We can now collect like terms, like we'll bring the x over to the left side, like so. That gives me negative 2x minus 8 equals negative 40. And we're going to add 8 to both sides. That leaves me with negative 2x equals negative 32. And then we'll divide by negative 2 on both sides. And that leaves me with x is equal to 16. All right, so now that we have solved for x, we go back to our original equations there to find their present ages. So that means the son is 16. And the father is 3 times 16. So therefore, 16 times 3, which is 48. So the son is 16 and the father is 48. All right, our next example, John is twice as old as Bill. So therefore, Bill is x. John is twice as old as Bill, so 2x. In 5 years, the sum of their ages will be 34. Find their present ages. So that means in 5 years, right? So 5 years into the future. So that means we're going to take our 2x and we're going to add 5. And here we're going to take our x and we're going to add 5. And it just says in 5 years, the sum of their ages will be 34. All right, so we're just going to take the sum of their ages. So 2x plus 5 plus the x plus 5 is equal to 34. All right, and now we just got to solve for x. So I'll collect like terms here. That gives me 3x. Collect that and that. So 3x plus 10 is equal to 34. Subtract 10 on both sides. 3x is equal to 24. Last step, we'll divide by 3 both sides. And that gives me that x is equal to 8. All right, so go back to the original. Find their present ages, so now. So that means Bill is 8. And John is 2 times 8, so 16. Next example, a mother is 3 years less than 5 times as old as her daughter. So X for daughter. The mother is 3 years less than 5 times as old as her daughter. So 5 times and then 3 years less, minus 3. Okay, so those are the expressions for the mother and daughter. If the sum of their ages is 39, find the age of each. So again, for this one, we're just adding these two together. So 5x minus 3 plus x is equal to 39. Collect like terms, 5x and 6, 5x, 1x, which gives me 6x, minus 3 equals 39. Add 3 to both sides. That gives me 6x is equal to 42. And then we'll divide by 6. And that leaves me with x is equal to 7. All right, so we're finding the age of each. So that means the daughter is 7. All right, and then we have to do this here to figure out the mother. So let's just do it here on the side. 5 times 7 minus 3. So 35 minus 3, which gives me 32. All right, so the daughter is 7 and the mother is 32. All right, so we were just finishing up this question here. So in 5 years, the sum of their ages will be 36. So we're just going to combine these two expressions here. So we have x plus 11 plus x plus 5 is equal to 36. So collect the like terms here. So that gives me 2x. Okay. Plus 16 equals 36. Subtract 16 on both sides. And then divide by 2. So we get x equals 10. And the question is only asking how old is Bruce. So Bruce is just x. So therefore, Bruce is 10 years old. And obviously, Madge is 6 years older, so Madge would be 16. But the question's only asking for Bruce. All right, so we'll stop here today.